It's Friday, April 10th, and this is Nighttime Mathematics Radio. Well, it's the end of another week, another one of these strange weeks where the homework goes on and on and on, and the classes are at best on Zoom, and at worst just sort of happens somewhere else. But that's okay. You've got a voice out here on the internet that will try to help you with your math questions, so you can keep getting the math done. Get on with next year as you'd planned. This is Nighttime Mathematics Radio. Show always works the same way. You go on to Twitter, tweet your math questions to @NightMathRadio, and please tweet specific questions. It's very difficult to answer a question like, I don't understand calculus. Because all I can say is, that's probably true, but not a question. And obviously I can't give an entire calc class over half an hour on YouTube, so what I'm going to do instead is try to answer specific questions. So it's much better if you take a picture of the problem you're having trouble with, send it on to me in Twitter. I'll try to answer it right here. So as always, let's take a minute or two to let people on Twitter ask any questions they're going to ask. And after that, if nobody's asked anything specific, we'll go to a question I found on the internet where people are asking hard questions about trig identities. So let's go through a few and see how they work. This is Nighttime Mathematics Radio. Welcome back, everybody. This is Nighttime Mathematics Radio. So that last question that got asked, somebody was asking about trig identities. Let's take a look. So the question that got asked looks like this. They said, I don't know how to do any of these. And here was the question, and here are the trig identities they're looking at. One moment. They had all sorts of problems. You had tan theta times cotangent theta is equal to 1. You had cosecant theta, cotangent theta is equal to secant theta. You have cosecant theta plus cotangent theta times cosecant theta minus cotangent theta is equal to 1. And there's more and more and more of these things. You have tan theta plus cotangent theta over tangent theta is equal to cosecant squared theta. And on and on and on. How do we do these things? Well, it turns out the answer is pretty straightforward. All these other trig functions, we talked about these in last night's show, are defined basically in terms of sines and cosines. Tan theta is sine theta over cosine theta. Cotangent theta is cosine theta over sine theta. Secant is 1 over cosine theta. And last but not least, cosecant is 1 over sine theta. So every one of these trig identities amounts to the same thing. Write down the expressions in terms of sines and cosines. Do fraction math, and this is the point where you really discover whether you understood how this all works from Algebra 2. Simplify the more complicated expression until it becomes the simpler expression, and then you're done. So let's start with the first one. We have tangent theta times cotangent theta is equal to 1. Well, that means that what you do is you start with this more complicated expression, tan theta times cotangent theta. We'll write each in terms of sines and cosines. And then you notice, hey, everything cancels. Sine divided by sine is 1. Cosine divided by cosine is 1. So that's equal to 1. But wait, you might ask, that this doesn't necessarily make sense, right? These don't have to exist, after all. Tangent doesn't exist if you're at pi over 2. Cotangent doesn't exist if you're at 0. Well, the problem very carefully stated at the beginning, assume 0 is less than theta is less than pi over 2. So you never have to worry about one of the denominators becoming 0. Because after all, if it did, the original expression wouldn't have made any sense. The cosecant times tangent one works the same way. You have cosecant theta times tangent theta is 1 over sine theta times sine theta over cosine theta. The sine thetas cancel because sine divided by sine is 1. So what's left is 1 over cosine theta. And sure enough, by definition, that's what a secant is. Equals secant theta. And that proves the trig identity. Now, occasionally you'll come up with a case where you'll say, well, wait, can I use a trig identity I've already derived? The answer is, sure. Once you've proven it, you can keep using it forever. And that can save you from having to go back to sines and cosines if you're lucky, because if you happen to remember all these things, then great, you can go back to you could use one to prove the other and you're done. But there's only so much you can store in your head. And the odds that you'll remember every last trig identity involving cosecants and cotangents a year after you're done with your trig class, or even honestly a few minutes after you're done with your trig class, is pretty much 0. But you can still remember what they mean. As long as you can remember that tangent is sine over cosine, as long as you can remember that cotangent is cosine over sine, you could always figure out how the trig identities work later yourself very quickly. So the goal here is not to keep all these trig identities memorized. That would be crazy. The goal here is to get enough practice with this sort of maneuvering that when you need a trig identity, you can prove it very, very quickly. It's the skill that's important here, not the actual memorization. Let's try the third one we had. We had one that said cosecant theta plus cotangent theta times cosecant theta minus cotangent theta was equal to something simpler. Well, let's expand this out using FOIL. Cosecant squared theta. In fact, we don't even have to use FOIL because this is a special form. This is a plus b times a minus b. And that's when you should just recognize that's a squared minus b squared. So in this case, that's cosecant squared theta minus cotangent squared theta. But wait, you just told me not to memorize things. Well, that's fine. If you use FOIL, you'll get exactly this. It just takes a little longer. Again, most of the memorization isn't necessary as long as you can rederive things fast. So that's great, but what do we do with this? You have to, after all, write these out. Well, once again, let's write them in terms of sines and cosines. Cosecant is 1 over sine, so cosecant squared is 1 over sine squared theta. Cotangent is cosine squared over cosine over sine, so cotangent squared is cotangent squared theta. Cosine squared theta over sine squared theta. So great, these have a common denominator. That's handy. Since these are fractions with a common denominator, we can just subtract the numerators. And it's amazing how many people have trouble remembering that's how this works when you have sines and cosines floating around. It's a thing you learned how to do when you were in 5th grade. But while there's numbers, it strikes people as easy. When there's sines squareds, it strikes people as hard. It's exactly the same thing. Because after all, theta has some value. It's a variable, so it's some number. So sine squared theta is some number, and this is 1 over some number minus some other number over that number. They're fractions. You subtract them like any other fraction ever. And now here's the one trig identity that really is worth memorizing. Remember, cosine and sine are defined in terms of the unit circle. We define cosine and sine to be the x and y coordinates, respectively, of a point on the unit circle at angle theta. So sine squared theta plus cosine squared theta is just the two short legs squared added together. So by Pythagoras' theorem, sine squared theta plus cosine squared theta is 1. And in fact, in trig, that usually gets called Pythagoras' theorem, because that's all it is. It's just Pythagoras' theorem written down in the unit circle. So 1 minus cosine squared theta, if you subtract cosine squared theta from both sides of this, must just be sine squared theta. Sine squared theta divided by sine squared theta is 1, because anything divided by itself is. So sure enough, that one's equal to 1. Let's look at the last one we have here. We have tan theta plus cotangent theta over tan theta. And we're supposed to prove this is equal to cosecant squared theta. Well, let's write this in terms of sines and cosines. That works well enough. We can add the things to add these fractions in the numerator. We need to find a common denominator, and you can see we can multiply sine and cosine. We can multiply this fraction by sine, numerator and denominator, to get sine theta, cosine theta in the denominator. Multiply numerator and denominator over here by cosine theta. So that gives us sine squared theta over sine theta, cosine theta, plus cosine squared theta over sine theta, cosine theta, all over sine theta over cosine theta. We'll deal with that part later. Let's add these up. We get sine squared theta plus cosine squared theta in the numerator, and we know what that is. That's 1. We just proved it. It's right over here. That's Pythagoras' theorem again. So you end up with 1 over sine theta, cosine theta, all over sine theta over cosine theta. And you look at this, you're like, it's a fraction with a fraction in the numerator and a fraction in the denominator. And as long as you remember fraction and division means exactly the same thing, you're fine. That means, yes, it's a fraction divided by another fraction. We can do that. You could have done that in 5th grade. It's just been a while. When you're dividing one fraction by another fraction, you take the reciprocal of the denominator and multiply. The cosines cancel. We end up with 1 over sine squared theta, which is, handily enough, secant squared theta. Cosecant squared theta, rather. Which is what we're asked to prove. That's every trig identity ever. When you're trying to prove trig identities, all you have to do is turn everything into sines and cosines, use the same fraction math you learned back in 5th grade to add the fractions as needed, to multiply the fractions as needed, and then when you're done, that's it. You turn whatever you have left back into secants and cosecants and tangents and cotangents or whatever you need, and you declare victory. This is Nighttime Mathematics Radio. Let's wait a little bit longer to see if anybody else asks a question on Twitter. If so, we'll come back and answer that question in the second half of the show. Otherwise, we'll end the show right there. See you back in a few minutes. This is Nighttime Mathematics Radio. Well, everybody, Twitter is silent. It's late on a Friday night. I think it may be time to end the show. Well, with thanks to Apple for all the strangest lyrics, the strangest, not lyrics, so it's the same strangest loops they've jammed into iTunes. The strangest loops they've jammed into GarageBand. Thanks to folks on the internet asking math questions. I think it's time to say goodnight. So in this weird world where there's math homework everywhere, but not a class to be seen, stay safe, everybody, and good night. See you Monday morning. This is Nighttime Mathematics Radio. Morning isn't a thing. So see you Monday evening at 9 p.m. for another episode of Nighttime Mathematics Radio. Good night, everybody.